Anyways, so I was testing the stream. Let me go to the other room so that I can. So this stream is about let's update. Sorry, let's teach. So what is let's teach? Let's teach is an app. It's a reusable app. It's an app that we are going to build in the stream. It's basically an app that you can install on your fastn powered websites. Right. So we have a few apps. So I'll show you what I'm talking about. Perfect. So for example, we have an app called Let's Update. Now this is a fast and reusable app means that you can install it on your own site, and I have installed it on my site, so you can see the app, right? So as you see, this is an app which is a full stack app. So it's kind of like in this case, my updates is a database powered whatever, right? Like hello live stream people, right? So uh, it's kind of like a mini Twitter or whatever, right? So you can go through it, and obviously this has a lot of things, features we want to add. But bottom line is key. The source code of what you saw was this, right? And and on the same site, we have, for example, let's say another app called Talk. Let's Meet. Sorry. So we have this Meet app. Right. So you have this app. In this case, it's an app that can be used for like a it's like a Google Meet replacement. Right? So you can again, and like I want to emphasize, both of them are on the same side, right? So the source is Let's Talk. So you go to that app, and Let's Talk is also a reusable Fasten app. So you can take a Fasten powered site and you can install all of these apps, and as you see, they have clean URLs. They kind of like gel well with each other, right? So for example, if you were to these two apps again, as you will see that they are both using exactly the same header, the same uh, footer, which is obviously which has just a line right now. But bottom line is both of those apps use the same set of fonts and all sorts of typography, color schemes, etc. So they are very um, cohesively part of the same site. So it's not like they're like like consider the sorry, Google Meet, right? Like if you have Google Meet, it's a Google site, right? Like it's not at all gelling with my site. Like if you have a Calendly, it is again a Calendly product. It's not gelling with your website. It doesn't use your logo. It doesn't use your fonts, typography, everything, right? It's like, so the idea that we have fundamentally is that can we take all these functionalities that you typically used by signing up with some SaaS company like Calendly or Google or all sorts of companies, right? So we are obviously reinventing, kind of, you can argue. So they are all these apps. For them to gel well together, right? They have to be able to reuse stuff, and um, yeah, so they are done in faster, right? So uh, I can actually show you how it is in case of Fifth, with you. Uh, so fifth.com, my site is hosted on fifth.com, and over here you will see, among other stuff, this is my site, and when I go to this site, I can go to the editor. So is a hosting environment as well as an online ID. And as you can see, I'm using let's talk over here, right? So as you see, I'm using the let's talk app that I mentioned, and also let's update app, right? And there are a bunch of things that we have to do to make it uh, really cohesive, etc. But in terms of number of lines of code, it's pretty tiny, right? So to install let's talk, this is what I have to do. I have to add a dependency on let's talk, and I have to also add my own like configuration. So all the configuration for let's talk app are actually provided by in this let's talk dot ftd file. So over here, as you can see, the only interesting configuration is these two who can create meetings. In this case, only Amit you can create meetings. Also, do we require verified accounts to be able to create meetings? Answer is false. I don't know why. That's must be I must be testing something at that time. And similarly, so that's it, right? So I've added just modified this file and added this no, I also added this line, let's say for meet, right? So for the let's talk app, I wanted the url to be /meet, right? So I can I have to add this app entry. So dependency basically adds a dependency. It's like, it gets added to your all the packages that are available, but not all dependencies are apps, right? So the apps that we are going to build are special kind of dependencies, which are actually apps. And the fundamental point about apps is that apps have a mount point where you're mounting them on your site. So I have selected the URL. I could have put mostly any URL, and I picked this one. Similarly, for updates, you can see I've used this URL, and yeah, and that's it, right? So it's kind of like uh, hopefully you'll see that it's really easy to add these apps, right? I mean, both of them are data-driven apps, for example, right? So, anyways, so let's go back to uh, building these. Right? So we are going to obviously go through this let's update from time to time, and so in order to learn, I'm not going to go into these existing apps. I'm only going to go and create a new app, right? So I'm going to create a new app and from scratch, right? So in order to create an app, you will use this template. So Swift community has published this template, and yeah, so let's use this. I am going to create a new repository using this template, and I'm going to put it inside no no Swift community, and I'm going to call it let's teach. Great. Uh, so this is what we are kind of going to build, and I'm going to keep it public so you guys can follow along. And so we have used the template, and it does this. So there's a bunch of things that we have to do to clean it up. So this is our repo again. Let's look at it. It's here. The URL is whatever, right? So if you try community slash let's teach, can be in your repo. It can be kind of anywhere. Uh, we have obviously the app name etc is not here, so there's a bunch of this xxx that you see that we have to fix. So I have given some instructions for this. uh, Before we start coding, I actually tend to want to usually add some basic stuff. So like for example a webhook. So I'm going to, so we have a Discord channel. So I'll show you. So all the apps that we are building, we have a Fifty Discord server, and in the Fifty Discord server, we go and create a channel for all the apps, and you can see other apps. For example, Let's Talk that we mentioned is here, and Let's Auth, and so on. So right now we are going to focus on the Let's Teach. So let's go and first change the icons because now it's going to go into the development stage. So we are going to copy this indicator, which means that this is now not just an idea but also under development. Perfect. And I'm going to go. I've created a webhook. I'll delete this webhook and I'll create it from scratch. So yeah. So basically, in the Discord, I go to the setting for that, edit channel, and go to integrations, and there are zero webhooks. So I'll create a webhook, and I will go and rename the webhook to GitHub webhook or whatever. Save changes, copy URL. Now I have to add this webhook into this webhook guy for the let's teach thing. So basically, what we want is any activity happening on the site to go to the Discord because that's where we collaborate, etc. So I want the developers, etc., to know what is happening, right? Like for example, let's teach has this activity happening. Let's talk has this activity happening right today at 8:30 p.m. Yesterday at 8:35. Or day before yesterday at 8:35 p.m. This commit was done by Ayush and so on. Right? So it's usually handy to keep track of stuff. So we go to GitHub, we add a webhook. I had copied the URL if you didn't pay attention. I'll do it again. Let's teach and integration and webhook and copy webhook URL. Go to the settings, yeah, and then I have to add this GitHub in the end /GitHub because that's how Discord tells you to do. The type of this webhook is going to be JSON, and we are not going to send just push, but a bunch of activities. So, for example, every time branch prediction rules are changed, usually you can add as many. Sometimes they become noisy, so I kind of leave them out. Code scanning alerts, why not? Collaborator added, removed, commit comments, deploy, depend on alerts, TK, deploy keys. Deployment status is sometimes noisy. Uh, issue command folks, issue labels. Largely you want most of these, but maybe you don't want. Okay, I'm going to just put the most important ones that I usually care about. Okay, you can keep tweaking this as an. So now we have to work on it, right? So we have this repo, so we are going to we have to first clone this repo. So get the URL and I go to any projects. So I put all my projects into this tilde/projects. So I go to that folder, get clone, perfecto, and now I'm going to open that. So I tend to use Rust Rover because obviously fasten apps are real fasten apps tend to well, they have a lot of Rust code. So this is my editor of choice. Where is these are the let's teach. New window, this window. I'll do it this window because I don't want this window anymore. I want to trust this project because Rust runs stuff when you open a project also. Okay, obviously right now this is not a proper project because it will not build properly. So we have to follow this. So we have to do XXX with the right name. So we will do Control Shift R and XXX, and as you see, we have already used the let's convention. So if we just replace x-axis with teach, we will be in good shape. So we will do this teach, replace r, and perfect. Now we have to rename the three directories. So there are these three directories. So let's go and rename it. Uh, doing a lot of indexing, etc. So a little bit slow. Hmm. Let's obviously we can write a script for this, which we hope to do very soon. So this part of the project would be faster and simpler, but let's do that. And we will get to what do these folders do and etc etc. Now because we have done this, we have a ready-made command, so we can just run this from this folder. So we'll go to the cd let's teach template, cd.packages doesn't exist from this, right? So I have to create this folder first, packages, cd.packages, and we do this. Okay, we use git add -f. So okay, let's see. We've done a bunch of stuff. Let's finish the whole thing. We we'll do this kind of. We have to do these also. So these are steps that we've already done. Let's do the other stuff. Let's do the whole thing. Files are modified. I'll leave them be for now. I'll leave these instructions for now. Okay. So where are we? So we have done a bunch of renames and a bunch of find replaces, and we have done this file, right? So this was a link that we created in one of the steps, and the things are, we have not verified things are working, but I am still doing it because this was a output of a mass rename stuff. So it's better to keep it as a commit and move it so that we don't have to, because this was a mass change. I tend to want to keep it aside and have a separate commit. So let's see if our commit hook is working. It is working. So as you can see, we have done some changes. Let me see what is happening here. Okay, this is Niti coming back. Where are we? General, something has happened in general. Fitha. Hello, Fitha. Okay. So yeah, so this is the commit we just did. Obviously, this part of the commit can almost be fully automated. We didn't have to take so long to do this, but it always helps to know what your automation is doing. So it creates confidence, etc. Now let's understand. So obviously the project is not fully ready, so we have to do these and then. But I'll do it in either time. So we have to make sure fastn is installed, which is installed. You can run this and so on. And now we have this source scripts auto.sh. So we have to do this. Uh, let's go here. Perfect. So let's take a look at scripts auto.sh. Sure, why not? So we have a project root folder, this thing which we normally put, and then we have a few environment variables. We have fastn binary, which tends to be fastn, but you can use your own fastn binary from a different location, etc. So db file, yeah. So because these are db files, we create a db file db.sqlite in this location, which is in your project root. And this is your database URL. You can use other databases, but we are SQLite. Anyways, some push copy random utilities. Now we are going to do a bunch of stuff. We are going to build Wasm. What is it complaining about? Why is it unreachable? Upgrade UI. So let's look at the folders. And so GitHub folder we are going to ignore. Backend is where all the backend code is going to live. So backend code is the Rust code that we are going to write. So it is the backend code. It's also of type cdilib, and this is going to be built using this build awesome, right? So we can run this if this works. What have I done wrong? I'm using this new beta shell thing by these guys. So build awesome. Let's see. Let's start with this. If it is working fine. So what is it doing? Let's study that in the meanwhile. So we have another script called build.wasm.sh that it is invoking. So the first step is we release it using this wasm32 target. So basically the Rust code that we run as part of fastn websites are all compiled to wasm. And so we build it. Then yeah, so I tend to use this folder home/target as my target folder. But a lot of people put the target folder in the current directory, which is also the default. If you do not override the target folder in Rust, Rust creates the target folder in the current folder. So because I do it here and some of my teammates do it here, or on the server we do it here, etc. So obviously we have this thing to like either of the two destinations. So basically we have this backend.wasm. So this backend, the name of this crate is backend. It's not meant to be published. So we have explicit publish calls. So all our projects backend is called backend. And the name of the backend file is backend.wasm. As you see, it got compiled and stored in my tilde/target/wasm32, and then in the release folder. So you see there is this backend.wasm file, which is the main thing. So it does copy it to this location, right? So as you see, we copy it to let's teach.fifttry.wasm, and we can check it out. Let's teach.site, and our backend.wasm is here. So this is, so as of now, we will not really look into this much. It doesn't really do much. As you see, it's pretty tiny Rust code. The most important thing is to lib part to make sure that this is WASM compatible stuff. And then we have this, we have a dependency on Surdy and FTS. FTS is mostly the main dependency that we have. it's saying that we are slightly old, so let's go and use the latest one. Let's build it again, and let's make sure that it is still building. Perfect. Looks like it is still building. Perfect. Uh, yeah, so mostly you have handlers. We have currently one handler called this hello handler. So this hello world handler is a processor. So uh, so you can visit this URL and see the output of this thing. We will do that in very quickly. It's returning this JSON. That's why we have the dependency on the. So FTSDK gives us this, and it's all very fine. So why is it red? Thing is red. Oh yeah, perfect. So so this is your backend, and as you saw, the backend code was copied into this over here, right? So let's see. Let's try to understand the folder structure more, right? So this is the backend we have seen. It has one API which is slash backend slash hello world, which is this is the code, and obviously this is the job of the backend. Now this file gets put into. So this is the main package, right? So this let's teach.fifttry.site is the main package, which is what you will be using, right? So if you remember, let's update. So this three folder structure that you see is pretty common. So we had this in the uh, let's say let's go back to let's update, for example. And in the let's update also we had these three folders, backend, etc. That's why we have the template. We can take a look at the backend of some more complicated stuff here. Let's say there's a create text post, so you can see, check out the source code of this. It's just regular Rust code. We do have, so we have created a module called DB, and we have stored some stuff in the DB. It's a, for DB we use Diesel, right? So we get this connection, and then we execute this Diesel. So it's all kind of like, if you've done Rust development, this is all pretty straightforwardish stuff. Just that it's interesting because it's in WASM. You may not have done WASM development for web server. Right? You might have used Actix or any of those HTTP libraries, but we do not use those HTTP libraries. We use our own FTSDK. One very interesting thing about FTSDK is, like, look at this function, right? This function is, it's not an async function, right? So this is the most interesting thing, that as per Rust, this function is not async, but it actually is async, right? As per WASM, it is async. So this is kind of like a sort of like a magical thing that we are doing. Like, for example, when you do this db.save, which calls this create function, and as you see, there's no async await calls anywhere, right? Like, and if you go back to the create text post db function create, right? So it's doing a db diesel execute call. It all feels and looks very sync code, and but underneath it is async, right? So it's kind of like a and that's all thanks to Wasm time library that you're using. So if you look at Wasm time, this thing, so we are using async. Come on. So we are using async runtime, and right. So all these functions, right? So if you look at this function. So when we are registering these functions to do the actual call, so for example, when you're doing the DB call, right? So underneath this, uh, somewhere it must be doing the DB call, and that DB call itself is async, right? So So basically, your WASM runtime pauses. So normally, when you run your processor doesn't pause technically, right? Like the process keeps on running while the backend stuff is happening, and the thread is could be paused and kept aside. But all of that is not happening inside WASM, right? There is no kernel inside WASM, etc. I mean, all of these things. So what happens is that the control flow jumps, right? So whenever you do that final call, whenever this function that we have registered, the corresponding backend function which is doing the DB call, wherever we have registered, if you want to take a look at it, yeah, it's a good idea to take a look at that part also. So we are using fastn obviously, and all of this magic stuff is happening inside this DS. Inside this DS create, you will see this thing called what the hell is this? Fast and DS 3D billion. No, we have moved it to fast and Wasm recently. So yeah, so all of that stuff is happening inside fast and Wasm, and the most interesting thing is the linker thing. Where are we linking export? These are. mm, oh no, this is the fast and Wasm. There is another fast and Wasm in this place. This is the one we are using. Sorry for the confusion. Project with long history. So yeah, register. So as you see, these are the functions which are available to your WASM code, right? So as you can see, all of these function names and corresponding to, if you look at the FTSDK, and so if you check out the FTSDK, which is the grade that we are using there, um, it has, let's say, so for example, let's say if you look at the diesel, yeah, so this is the connection thing, right? So whenever we are doing the connect call, right? So somewhere we must be doing the connect call, which will open the database connection, right? So we are basically saying कि there exists this function called SQLite connect, whose type is this, and you can ignore this input and output parameter because WASM doesn't deal with higher level data structure data types. It deals with this lower level data types, which are largely pointers and stuff. But the bottom line is that you can study all of this. The bottom line is that there's a function called SQLite Connect, which is basically one of the functions would be here. So as you see, this is the SQLite function. So WASM, your WASM code calls FTSDK, which somewhere internally calls this connect, and the connect call, right? As you see, we have this connect call happening. Where are we calling the connect call? Over here, right? So we are doing the connect call, right? And this connect call, as soon as you do this connect call, right? So if you see again, this function is sync, right? So if you do the connect call, um, this function is called. Now this function is provided by over here, right? So this is what we have said. Okay, whenever somebody calls from WASM side to our connect, to call this guy SQLite connect, right? Now let's check out our SQLite connect, and actually, SQLite is not a good example because I think it is already the crate itself that we are using. Let's look at Connect because we started. But over here, it's this is also a good example because so as you see, SQLite Connect function itself is async, right? So it is kind of like why is it sync here, right? Over here, this function is not async, but and even this function is not async, but over here this function is sync. So basically the entire WASM time runtime pauses there whenever you call that, and control flow jumps from WASM to our Rust code to the host Rust code, which is the fastn code. So now fastn receives this call, and it does its own stuff, which is this. It will call this. As you see, this is why I was saying this actually doesn't do anything async. As you see, this one is because SQLite actually doesn't expose itself as a async library. But if you look at the HTTP or let's say, for example, send request, right? So when you're doing the HTTP request, over here we will see a bunch of await, right? So there is an await call here, and then there's a so yeah. So this is the magic that I was talking about. So the magic is this, that when we are writing our code, right, we do not write async anywhere, right? We don't. Uh, and the advantage of that is you don't have to worry about async, right? So async is something that you have to learn, right? There's a lot of things you want to, like if you look at the, again, look at the function signature, right? These tend to be scary, right? They tend to have these lifetimes, which tasks, which async tasks are static, which are not static, which can be transferred across threads, which cannot be transferred across threads. These are all complexity that you have to deal with when you are writing async code. They tend to capture stuff and blah blah. Um, Here there is no capture getting created, right? There's no feature object which is getting created, and you don't have to worry about what is the lifetime of the data which is inside this function. But had it been an async function, you would have to worry about it. And so, like for example, this static means that all the stuff captured by this closure, right? So this or whatever the future whose output is whatever is static, right? It can live as long as whatever. So so by not having to worry about async while you're writing fastn code, we have simplified your life, right? If you are using Actix, if you are using any of the other Rust backend, you have to worry about async. Here, you don't have to worry about async. Right? That's a major feature, in my opinion. It simplifies your life. It simplifies the lives of a lot of people, and yet you get the benefits of async. Right? Your server is still doing async stuff, but your code is not async. Right? It's like Go, a bit like Go. Right? Go code is obviously async, but you don't have to think about which part is sync and which one is async, right? That's, to me, the very magical feature that Wasm gives us, right? The whole function coloring thing is a big, considered a big no or big problem for Rust guys, right? When you're learning Rust, you have to learn about all of this complexities, which are function coloring related complexities. And Rust team is working hard to try to solve these async related problems that come. But obviously, not using async just eliminates that class of problem, and that's what we have done. And so that's the uh, anyways, so we've gone too much in detail about this. So we are going to actually run it now and to see how things. So we built our Wasm. Now the question is, how do I run it, right? So now we have a bunch of these. So we want to run two things: either run UI or run template. We can run any of the three things. There's actually another folder called, we have not really discussed. So we have said that let's teach is the main folder, which is the thing that is going to contain your uh, actual application and usable application. If you're writing, this is what people will be installing. So um, when we publish it, this wasm file will be published along with this package. So only these packages, these files will be downloaded by you when you're using this package, right? So these other ones. So this is going to be the homepage of the site. So let's look at them. So we can go to CD, let's teach template and fastn serve, and it will, looks like something wrong with my network, or I don't know. Let's try whatever. So it's downloading all the dependencies. All the dependencies would be stored in the .packages folder. So we are right now doing this inside template. So we are running a template now. So congratulations, the template is working, right? So something has happened, and now let's try to understand. So this is the template. This is the package that we are running. So the name of the package is whatever. So the idea of the template is that this is what you'll use in your actual package. So you'll probably never use this template. This is like like a demo of this package, how to use it, like the end user, how the end user will use it. So um, so it has these two apps installed. So we are going to so for example, this has the auth installed, right? So the beautiful thing is the auth is installed, which means the on the URL slash dash auth, right? So let me get rid of this guy uh, here, right? So we are not logged in. So this particular URL slash dash auth, as you see, which is here, is provided by the Let's Auth. So I have my template has an auth because obviously Let's Teach is going to require auth. So we don't have to worry about. And this is a full-blown auth package, and you can create an account and blah blah. We are not going to do all of that. Um, so and then here it is using Let's. This is using the wrong URLs. Let's fix this URL. So we are going to need a Let's Auth, Let's Teach. Let's Teach will be provided by Let's Teach. So we have to create this file, new file. It should have been here. I think this package is not correct now. The template that I've created is not awesome. So I will fix this. And then, yeah, this should be, let's call it, what are we going to teach? Let's just call it teach. It will be eventually a better URL. So now we'll go to, so every time you modify fastn.ftd, you have to restart the server, unfortunately. Yeah, it does check the, what is called, if all the packages are up to date or not every time you start. So I tend to use offline flag so that you go straight to the server without checking the dependencies. So things are still working fine. And now let's go to Let's Teach. So Teach is this app, which is an empty app. So let's do the development. So this is our Teach app, and as you see, it is kind of so the most interesting thing from your point of view is that this file is the file, let's say, so this is the file which is loaded, right? So when you visit this URL slash teach URL, so that like, try to understand what is happening, right? So this guy is saying ki mount this particular package on this URL, on this path, meaning that any request that goes to this path, right, and onwards, right? So any slash teach slash whatever uh, will be actually handled by this package, which is over here. And if you pay attention to this guy, you see that this Let's Teach is a local package, meaning that we can edit this package right here without having to publish and blah blah. So, and that's why in the beginning steps, if you remember, we did this linking. So this one is a link. It's a soft link to this location. If you open the content and look at the index.ftd file, it will be the same index.ftd file that we just created. Hello teach. Right, so this file and this file are the same files, and thanks to the magic of linking, right? Uh, so, so that's the most interesting thing. So this is our Teach app getting installed. So as of now, Teach app function provides this functionality, which is just the text. There are a bunch of stuff that I have created, which I do want to kind of delete because they're all related to one of the apps that I was previously building. So we will ignore all of this. These pages don't actually exist. Another very interesting thing that we have is like, if you see that we don't have a file like, or we do have a file like this. But even whether we have this file or not, this will not give an error unless you use these things. So we will come to this later and talk about it more in detail. So as of now, my site is just this. Let's simplify our life. And this is our Let's Teach app, just to verify yo. So it's going to yo. So now we discussed the backend URL. was, let's see if the backend is working or not, right? So this is the backend URL. So we can do curl 127.0.0.18000, and now this is teach slash backend slash hello world, right? And this returns the JSON. So this is the magic, right? So because it has to be slash teach, then only the request will go to this folder. Otherwise, the request would be resolved over here. So we want the request to go to inside this. So this backend is .wasm is not really a single file from our perspective. It is kind of like a, how do I say it? Internally contains all the paths that we have implemented. So, anyways, so this is how you run this Rust code, and as of now, I think we have not yet done any DB calls yet. So the db.sqlite file has also been created. So we can take a look at that. SQLite. Right, so db dot, what is it called? db.sqlite tables. So as you see, we have a table called this and session and a bunch of other things that we are. These will not be needed in this particular app. So yeah, so that brings us to where the hell is a migration, right? Where did these tables come from? So there are three tables here. So a bunch of these tables are over here. So as you see, these tables are, so whenever this package is obviously loaded by, so whenever the let's teach is loaded by this guy, the migration file, so the migration is defined over here. So this is the initial migration. I will go and delete this. So this is a bunch of tables that I'm creating. This again, you can ignore these tables because this is for the previous project that I was using. But we'll leave this migration line maybe right for now to study. So yeah, you create these tables. The table got created for you, and etc. So I hope that you realize it's pretty kind of like a magical-ish. Obviously, we try to do a lot of documentation also. Obviously, we are pretty bad at documentation, but we hope to become much better. So yeah, so in the design folder, you will hopefully have a schema where we'll mention all the tables, these tables that we are creating, so that you can understand what is going on in the internals. Right? This is not some opaque. So one of the very important thing that we aim for is that if you install this app on your own site, you become the owner of the data of this app, right? And when you become the owner of the data, it is very, very important that you completely understand the schema of the data and fully understand what is going on. We don't want it to be like a black box approach, like just this is what it is and don't. So we want to document it, and because we strongly believe the data and the documentation is the main thing that you own, right? What does this app do? Not how does it do, but what does it do, and what is the database that it has used so far to create the data of, like, so these are the two things you own. The software can be rewritten, whatever, right? Like it keeps going through the churn. Software is not the real IP. The real IP is the documentation and the data. Anyways, so and we want you to own all your data, right? So the idea of these apps that we are creating, that all of these apps together, we will teach you the database schema of all of these apps. We will teach you all the APIs exposed by all of these uh, apps and so forth, right? So we will but that's the only way you become like free and independent, right? If you don't know how does your fridge work or car work, and the only thing you can do is, oh my god, there's a bug in your car, you have to change your tire and you go to the manufacturer and the whole car is a black box and you can just not even tighten the screw of your car, then of course you're not really the owner of your car, right? So to me, if you own the car, you mean that you have full, like, you know what is going on inside the car and you can fully repair the car and blah blah, and that's the true ownership. So we are going for that true ownership of all your apps, right? From your photos app, reminder, mail. So hopefully very soon all of these apps would be available to you as a fast and reusable app that you can put in your website, and that single db.sqlite will contain all the stuff that you have, right? Like across all of these apps. And obviously, it will require certain amount of attention to detail. And we are not hyperscale. I mean, obviously, fastn can be hyperscale, but when we are building these apps, we are building them for running your organization or running your personal or family, etc. We are not running it for creating your own Twitter. Nothing is there which will preclude it. For example, we do support PostgreSQL, and obviously with some tweaks, very soon we will change the default database. In fact, as you saw, this is how we specify the default database. So you can actually use all of this with another database, but the apps that we are building, they are all built with the assumption that they are SQLite, which means the schema, etc., the table, etc. This statement is a SQLite specific statement. Obviously, tomorrow we will mention that DB SQLite or something, so that you can have like DB all or whatever generic or something, so that if you're creating a reusable app which supports both SQLite and PostgreSQL and whatever Mongo, MySQL, whatever, then we don't actually want to support no SQL database. We believe SQLite and PostgreSQL is what we really want to support. So yeah, so you will have both these supports, and obviously you will have to write corresponding stuff, like the SQL queries have to be updated. Similarly, the Rust code also has to be updated to optimally use the functionalities provided by the database. Right? But yeah, so by default we do Boston, and we do intend to all the fastn apps tomorrow will support both SQLite and PostgreSQL. Currently, they only support SQLite because of like that's all we have been able to do so far. But yeah, so if you look at fastn itself, does support both. fastn.com/SQL. If you go check this out. Um, so we have both SQLite and PostgreSQL supports. So yeah, you can also write the SQL query directly in your fastn file. We'll see that. So you don't have to necessarily write everything in your what is called Rust. So the goal is to make fastn more and more powerful. So currently fastn is powerful enough to make these queries and render the output in the on the page, right? In fact, there is a proof of concept use to do app which is fully written in just fastn without Rust, right? So it does insert, update, delete, all of those stuff um, directly in fastn. I would not say the experience is great. It has a lot of stuff that we are not too proud of. It kind of works somehow, but in 0.4, the fastn 0.4, the fastn language, especially the portion which is used to create reusable functions, that is very not developed. So the function that you're creating in raw fastn, in the fastn native functions, they are kind of pretty not great. They kind of almost directly call it a JavaScript function. They just take the input, validate that, type check the input, and then call a JavaScript function. So they there you can't yet do if then else loops, all sorts of stuff, right? So they just and in 0.5 hopefully this will whatever fixed. Anyways, so yeah, so we have created this. Let me go and check out the what all have we done. So we have updated the FTSDK version. We have updated the URL. We have removed the random stuff. With commit Perfect. So we are going to pause our recording. We'll do a series of streams. So